So this time I will show you an animated video related to what a transistor is. My name is Al-Farabi Lama, NIM 241,011,060,024. Let's go straight to the animation. What is transistor? A transistor is a semiconductor device that can work as an amplifier, electronic switch, or electric current controller. They are made from semiconductor materials, such as silicon or germanium, whose properties can be altered by doping techniques to improve their ability to conduct electricity. The main function of a transistor is to control the flow of electric current between its two terminals through a small signal applied to the third terminal. Its ability to amplify signals and work as a switch makes it a vital component in various electronic applications. History of the invention. The transistor was first invented in 1947 by John Bardeen, Walter Brattain, and William Shockley at Bell Laboratories. This invention replaced the vacuum tube technology previously used in electronics. Transistors are smaller, more efficient, more durable, and require significantly less energy compared to vacuum tubes. Next, the transistor has three main parts. First, there is the base. Base beat the control terminal that regulates the flow of current between the emitter and the collector. Typically, a small current at the base can control a much larger current at the collector. Second, there is the emitter, the terminal that serves as the source of electrical current, which will later flow to the collector. Third, there is the collector, C, the terminal that receives current from the emitter through the base. Next, we move on to logic gates. What are logic gates? Transistor logic gates refer to the concept where transistors are used to construct logic gates, which are fundamental components in digital circuits that perform binary logic operations such as AND, OR, NOT, NAND, NOR, XOR, and Zoner. Logic gates are the foundation of digital computing systems, and combinations of various logic gates form the processing units, memory, and other electronic devices. Logic gates are electronic devices that operate on binary input signals that can only have two possible values, 0 or 1, and produce binary output signals based on predetermined logical rules. The operation of each logic gate is determined by its input signals and logical function. Logic gates can be combined in various ways to perform more complex logical functions. These gates are the fundamental building blocks of digital electronics and are used to construct digital circuits, such as computers, calculators, and other electronic devices. Before entering the first logic gate, I will first explain the truth table. A truth table is an essential tool that helps understand how logic gates work and how to use them to solve problems. It provides a clear way to analyze the behavior of logic gates, such as AND, OR, and NOT, when given different input values. The truth table shows the logical output of a logic gate for all possible combinations of its inputs. It consists of rows representing each possible combination of inputs and columns for each output generated based on the type of logic gate. The inputs and outputs in a truth table are written in binary values, 0 and 1, where 0 represents false and 1 represents true. Alright, let's go straight to the first logic gate. First, the AND gate. The AND gate produces an output of 1 only if all its inputs are 1. If any input is 0, the output will always be 0. The OR gate produces an output of 1 if any of its inputs is 1. This means the output is 0 only if all inputs are 0. The NOT gate produces an output that is the opposite of its input. Thus, if the input is 1, the output is 0, and vice versa. The NAND gate is a combination of AND and NOT gates. It produces an output opposite to that of the AND gate. This means the output is 0 only if all inputs are 1. The NOR gate is a combination of OR and NOT gates. It produces an output opposite to that of the OR gate. This means the output is 1 only if all inputs are 0. The XOR gate produces an output of 1 if one of its inputs is 1. The output is 0 if both inputs are the same. The zoner gate produces an output of 1 if both inputs are the same and 0 if the inputs are different. Those are the types of logic gates. Thank you for watching.